Welcome and core concept. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today, we're embarking on a comprehensive journey into Azure Application Gateway. It's much more than a simple load balancer. It's a sophisticated application delivery controller. ADCA's standard load balancer operates at Layer 4, the transport layer, distributing traffic based on IP addresses and ports, like a mail carrier delivering letters to a building's address. Application Gateway, however, operates at Layer 7, the application layer. This means it can read the contents of the HTTP request itself, the URL path, the host header, and more. It's like a receptionist inside the building who can read the recipient's name on the letter and deliver it to the right person on the right floor. This intelligence allows us to build highly efficient, secure, and complex routing scenarios for our modern web applications. Core Components Overview. To truly master Application Gateway, we must understand its DNA. Let's use an analogy of a corporate mailroom. The front-end IP is the building's street address, the single, public point where all mail arrives. The listener is the mail slot for a specific type of mail, say, express mail arriving on port 443. It is constantly watching for incoming packages. When a package arrives, the listener gives it to a routing rule. This is the mailroom sorter who reads the to address inside the package, like the URL path. Based on this, the sorter decides which department it goes to. The destination department is the backend pool, a group of employees, your virtual machines or app services, ready to handle the package. To know how to deliver it within the department, the sorter follows HTTP settings, which are instructions like deliver to desk port 80 and use the internal, unencrypted memo format. Finally, the health probe is the floor supervisor who constantly walks around, checking if employees in the backend pool are at their desks and ready to work. If someone is sick, the supervisor tells the mailroom not to send them any more packages until they are healthy again. This ensures a reliable and uninterrupted workflow. Planning and design considerations. Before writing a single command, proper planning is essential. First, you must decide on the SKU, which stands for Stock Keeping Unit. Standard version 2 provides autoscaling, zone redundancy, and better performance over the legacy version 1 SKU. WAF version 2 includes all version 2 benefits, plus a powerful, built-in web application firewall. For any production workload, WAF version 2 is the highly recommended choice for security. Next, consider VNet and subnet design. The application gateway requires its own dedicated subnet where no other resources can be deployed. You must allocate a sufficiently large CIDR block for this subnet to accommodate the gateway's scaling needs. A /24 is often a safe choice. Finally, think about sizing and capacity. For the version 2 SKUs, capacity is more flexible due to autoscaling. You set an initial and minimum instance count. A capacity unit is an abstract measure of performance, compute, persistent connections, and throughput. You can start small and let autoscaling handle increases in traffic, while setting a minimum capacity ensures you always have a baseline level of performance available. Foundational step. Resource group. Our journey begins with the most fundamental building block in Azure, the resource group. Think of it as a logical folder or container. Everything we create for this project, the virtual network, the public IP, the gateway itself, will be placed inside this group. We use the command AZ group create. Let's break it down. AZ is the entry point for the Azure command line interface. Group is the command group for managing resource groups. Create is the action we want to perform. This command has two mandatory parameters. The name parameter, here my app gateway RG, gives our resource group a unique, human-readable name within our Azure subscription. The location parameter, here East US, specifies the Azure data center region where this resource group's metadata will be stored. Choosing a location close to your users can reduce latency. This command, Upon successful execution, returns a JSON object confirming the creation and its properties. Foundational step: virtual network. Next, we create a virtual network, or VNet. A VNet is your own private, isolated section of the Azure cloud. It's where your resources, like virtual machines and the application gateway, will live and communicate with each other securely. The command is AZ-network VNet create. Let's examine its parameters. Resource group My app gateway RG tells Azure to place this new VNet inside the resource group we just created. Name My VNet gives the network a unique name within the resource group. The address prefix 10.10.0.0/16 parameter is crucial. It defines the internal, private IP address space for the entire VNet using CIDR notation. A /16 prefix provides private IP addresses, giving us plenty of room for our resources and future subnets. This is not a publicly accessible range. It's for internal communication only. Foundational step 3. The dedicated subnet. Within our VNet, we need to create subnets to segment our network. A critical, non-negotiable rule for application gateway is that it must reside in its own empty, dedicated subnet. You cannot place any other resource, like a VM, in the same subnet. This allows the Azure platform to manage the underlying network infrastructure for the gateway without any interference. We use AZ-network VNet subnet create. Resource group and VNet name specify the parent VNet for this new subnet. Name My app gateway subnet gives our dedicated subnet a clear, descriptive name. The address prefix 10.10.0.0/24 parameter carves out a portion of the VNet's address space specifically for this subnet. A /24 prefix provides 256 IP addresses. Azure reserves a few addresses in each subnet, but this is typically more than enough for the gateway's internal needs, even with autoscaling. Foundational step. The public IP or application gateway needs a public-facing address so users on the internet can reach it. For this, we create a public IP address resource. The command is AZ-network public IP create. Resource group and name are our standard identification parameters. The SKU standard parameter is very important. The V2 SKUs of application gateway exclusively require a standard SKU public IP. The standard SKU is zone redundant by default in regions that support availability zones and is backed by an Azure SLA. The old basic SKU is not. The allocation method static parameter ensures that this IP address is reserved for our use and will never change, even if the gateway is stopped or restarted. This is essential because you will point your website's DNS records, for example www.yourcompany.com, to this static IP address. Deploying the gateway. With our network foundation, resource group, VNet, dedicated subnet, and static public IP fully prepared, we can now deploy the application gateway instance itself. This is the main event. We use the AZ-network application gateway create command. Resource group and name identify our new gateway. Location must match the location of our VNet. The SKU WAF v2 is our choice of performance and security tier. As discussed, this gives us autoscaling and a built-in web application firewall. Public IP address My app gateway PIP links the static IP we created, making it the gateway's front end. VNet name My VNet and subnet My app gateway subnet place the gateway into the prepared, dedicated subnet. This is where it will live on the network. Finally, we manage capacity. Capacity 2 sets the initial number of instances the gateway will deploy with. For the V2 SKU, this is a starting point. Min capacity 1 instructs the autoscaler that it should never scale down below 1 instance, ensuring our gateway is always available and avoids cold start delays. Step 3. Configuring backend pools. Now that our gateway exists, we need to tell it where to send the traffic it receives. The destination for traffic is a backend address pool. A backend pool is simply a logical grouping of the backend resources that will serve the application content. The command to create one is AZ-Network Application Gateway Address Pool Create. Resource group and gateway name specify which application gateway we are modifying. Name Pool Web Servers gives our pool a descriptive name that reflects its purpose. The server's parameter defines the members of this pool. You can provide a comma-separated list of private IPs addresses, as shown, or you can use fully qualified domain names, FQDNs. Using IPs addresses is common when your backends are virtual machines within the same VNet. FQDNs are useful if your backends are platform as a service services like Azure App Service or even external servers. Step 4. HTTP Settings. Part 1 Basic. Just knowing the address of the backend servers is not enough. The gateway also needs to know how to communicate with them. This is defined by HTTP settings. These settings control the port, protocol, and other behaviors for the connection from the gateway to the backend pool. We use AZ-Network Application Gateway HTTP settings create. As always, resource group and gateway name identify the gateway we are configuring. Name HTTP settings 80 gives our settings a logical name. The port 80 parameter instructs the gateway to forward the incoming traffic to port 80 on the backend servers. Protocol HTTP specifies that this communication will be unencrypted. HTTP request timeout 20 sets a timeout in seconds. If a backend server does not respond to a request within 20 seconds, the gateway will consider the request failed. This prevents users from waiting indefinitely for a non-responsive server. Step 4. HTTP Settings Part 2 Advanced. Let's enhance our HTTP settings with more advanced features for a better user experience and graceful management. We use the update command to modify our existing settings. The command is AZ-Network Application Gateway HTTP Settings Update. We target the settings named HTTP Settings 80 that we just created. Cookie-based affinity enabled activates what's known as sticky sessions. When a user first hits the website, the gateway sends them to a backend server and gives their browser a cookie. For all future requests from that user, the gateway will read the cookie and send them back to the same server. This is critical for stateful applications that store session data like shopping cart items locally. Connection Draining Timeout 30 is a feature for graceful backend removal. When you need to take a server out of the pool for maintenance, this setting tells the gateway to keep existing connections to that server alive for 30 seconds, allowing active users to finish their transactions. No new connections will be sent to the draining server, ensuring a seamless experience. The listener. The listener is the component that actively listens for incoming traffic on a specific port and IP address. Without a listener, the gateway is deaf and will not process any requests. Creating a listener is often a two-step process via the CLI. First, we need to explicitly define a front-end port we want to listen on. We use AZ-Network Application Gateway Front-End Port Create. We name it port 80 for clarity and specify port 80. Next, we create the listener itself with AZ-Network Application Gateway HTTP Listener Create. We give it a name, Listener HTTP, and associate it with two key components. Front-end IP App Gateway Front-end IP, which is the default name for the gateway's public IP configuration, and Front-end Port port 80, which is the port object we just created. Now, our gateway is officially listening for HTTP traffic on port 80 of its public IP address. The basic rule. We have all the individual pieces. A listener to accept traffic, a backend pool to serve it, and HTTP settings to define how to talk to the pool. Now we need to connect them. This is the job of a routing rule. We use AZ-Network Application Gateway Rule Create to build this connection. We give our rule a name, Rule Basic Routing. We specify the rule type Basic. A basic rule provides a simple, end-to-end mapping from one listener to one backend pool. Then we connect the components. HTTP Listener HTTP tells the rule to process traffic that comes from our HTTP listener. Address pool web servers specifies the destination for that traffic. HTTP settings 80 tells the rule to use our configured settings for the connection. With this rule in place, our gateway is now fully functional for basic routing. Traffic arriving on port 80 will be forwarded to our web server pool. Step 7. Health Probes Part 1 Creation. A load balancer's core function is to ensure reliability by only sending traffic to healthy servers. It determines server health using health probes. While a default probe exists, creating a custom probe gives us precise control. We use AZ-Network Application Gateway Probe Create. Let's dissect the parameters. Protocol HTTPS is a great choice as it validates not just that the server is listening, but also that its SSL/TLS certificate is configured correctly. Host www.your-domain.com is critical. It sets the host header for the probe, telling a multi-tenant web server which specific site you want to check. Path/healthz specifies a custom health check endpoint. This is far better than probing the homepage / as a /healthz page can be designed to do a quick check on dependencies like a database, giving a true signal of application health. The timing is controlled by interval 30, probe runs every 30 seconds, timeout 20, probe fails if no response in 20 seconds, and threshold 3, server is marked unhealthy after 3 consecutive failures. Step 7. Health Probes, Part 2 Association. Creating the health probe is only half the battle. By itself, the probe does nothing. We must explicitly associate it with a set of HTTP settings. This tells the application gateway that when communicating with the backends defined in these HTTP settings, it should use this specific probe to determine their health. This design allows you to have different probes for different backend pools. For example, your web servers might have a probe checking an HTML endpoint, while your API servers might have a different probe that expects a specific JSON response. We use the AZ-Network Application Gateway HTTP Settings Update command. We target the gateway and the specific HTTP settings we want to modify, HTTP Settings 80. The key parameter here is probe custom. This replaces the default probe with our new, highly configured probe for any backend pool that uses these HTTP settings. Step 8. SSL/TLS Termination. Part 1, Certificate. SSL/TLS termination is the process where the application gateway handles the expensive work of encrypting and decrypting HTTPS traffic, freeing your backend servers to focus on serving content. The first step is to provide the gateway with your SSL certificate. In a real-world scenario, you would purchase a certificate from a trusted certificate authority, CA. For this demo, we can generate a self-signed certificate using the Open SSL toolkit. The commands shown on the slide first create a private key and a certificate signing request, then create the certificate.crt. Finally, it bundles the key and certificate into a password-protected .pfx file, which is the format the application gateway requires. Once you have the .pfx file, you upload it to the gateway using AZ-Network Application Gateway SSL Cert Create. Gateway name and resource group identify the target gateway. Name My SSL Cert gives the certificate a friendly name for reference. Cert file points to your .pfx file. Insert password provides the password you used to secure it. With our SSL/TLS certificate securely uploaded to the gateway, we now need to create a new listener, or update an existing one, to handle HTTPS traffic. This listener will perform the SSL termination. First, we create a new front-end port for the standard HTTPS port, 443, using AZ-Network Application Gateway Frontend Port Create. Then, we create a new HTTPS listener with AZ-Network Application Gateway HTTP Listener Create. We name it Listener HTTPS. We link it to our public IP and the new front-end port 443. The most important parameter is SSL Cert My SSL Cert, which is the friendly name we gave to our uploaded certificate. This tells the listener to use this certificate to negotiate secure sessions with clients. Finally, we need a new rule to connect this HTTPS listener to a backend. Here, rule HTTPS connects our new listener HTTPS to the same backend pool. Now, traffic arriving on port 443 will be decrypted by the gateway and then forwarded as unencrypted HTTP to the backend. Path-based routing. Path-based routing is where the Layer 7 intelligence of Application Gateway truly shines. It allows us to route traffic to different backend pools based on the URL path requested by the user. Let's say we want /images/star to go to a pool of servers optimized for image delivery, and /video/star to go to another pool. First, we need to create the new backend pools pool images, pool videos, and corresponding HTTP settings. Then, we create a URL path map using AZ Network Application Gateway URL path map create. This map media, acts as a container for our path rules. We must specify a default address pool and default HTTP settings to handle any traffic that doesn't match a specific path. Inside this map, we create rules with AZ Network Application Gateway URL path map rule create. We create rule for images, which maps the paths/images/star to the pool images. We do the same for videos. Finally, we update our main HTTPS routing rule HTTPS to use this path map media instead of a basic backend pool. This activates our content-aware routing logic. Step 10. Web Application WAF. Having deployed the WAF v2 SKU, we have a powerful security engine at our disposal. Now, we'll configure it to actively protect our application from common web-based attacks like SQL injection and cross-site scripting XSS. We use the command AZ Network Application Gateway WAF config set. We target our gateway and set enabled true to activate the WAF. The firewall mode prevention parameter is key. In prevention mode, the WAF will inspect traffic and actively block any request that matches a malicious signature. The alternative is detection mode, where it only logs threats, which is useful for initial testing to check for false positives. For production, prevention is the goal. The rule set type OWASP and rule set version 3.2 parameters instruct the WAF to use version 3.2 of the Open Web Application Security Project's core rule set. This is a battle-tested, industry-standard set of rules that provides an excellent baseline of protection against the most common vulnerabilities. Management and conclusion. Our journey has taken us from foundational planning to deploying a secure, intelligent, and resilient application gateway. We've configured listeners, backend pools, advanced HTTP settings, custom health probes, SSL termination, path-based routing, and a web application firewall. For day-to-day management, you have several useful commands. AZ Network Application Gateway Show will give you a complete JSON output of the gateway's entire configuration, which is invaluable for auditing and troubleshooting. If you need to perform maintenance or cut costs in a development environment, you can use AZ Network Application Gateway Stop to deallocate the gateway and pause billing, and AZ Network Application Gateway Start to bring it back online. You now have a production-grade application delivery controller configured entirely through the command line, giving you a powerful, repeatable, and automated way to manage traffic to your applications in Azure. Thank you for your attendance. Please consider subscribing to the channel.